At this very moment, a spacecraft created in the 1970s is still traveling through interstellar space at over 17 kilometers per second. It is now nearly 24 billion kilometers away from Earth. Any signal it sends takes more than 22 hours to reach us, and our reply takes just as long to return. It runs on slowly fading nuclear power and uses technology designed long before modern computers became common. Yet against all odds, it continues to send back information that doesn't always match what scientists once expected. This spacecraft was never intended for such a long journey. Its original mission was only meant to last a few years, focused on exploring the outer planets before eventually going silent. But decades later, it has moved beyond the Sun's influence and entered interstellar space, continuing to reshape our understanding of what exists beyond our solar system. The story begins in the early 1970s, when an engineer discovered a rare alignment of the outer planets. Jupiter, Saturn, Uranus, and Neptune were positioned in a way that would allow a spacecraft to use their gravity to gain speed and travel farther than ever before. This opportunity happens only once every 175 years. It led to the idea of a grand tour, a mission that could explore multiple planets in one journey. However, due to limited funding, the plan was reduced to two smaller spacecraft, primarily aimed at Jupiter and Saturn, with only a possibility of going farther. Voyager 2 launched first in August 1977, followed by Voyager 1 in September. Despite launching later, Voyager 1 was set on a faster path and reached Jupiter first. Both spacecraft carried scientific tools like cameras, spectrometers, and detectors, along with a symbolic golden record containing sounds and images from Earth. When Voyager 1 arrived at Jupiter in 1979, it revealed a far more active world than expected. One of its moons, Io, was found to have erupting volcanoes, the first ever seen beyond Earth. Another moon, Europa, showed a smooth, icy surface, hinting at the possibility of a hidden ocean beneath. Jupiter itself displayed massive storms, powerful lightning, and an enormous magnetic field. At Saturn, the discoveries continued. Its rings turned out to be made of countless thin structures with complex patterns. The moon Titan had a thick atmosphere rich in organic compounds, raising questions about chemical processes similar to those that may have led to life on Earth. Voyager 2 continued onward, reaching Uranus and Neptune. Uranus was found to be tilted on its side, creating unusual seasonal behavior, while Neptune showed extremely fast winds and dynamic storms. Its moon Triton displayed icy eruptions despite its freezing environment. After completing their planetary missions, the spacecraft continued moving outward. Voyager 1 eventually reached the edge of the Sun's influence, but this boundary turned out to be far more complex than expected. Instead of a sharp edge, it encountered a region filled with turbulence and shifting magnetic activity. When it finally entered interstellar space, the transition was gradual and confusing, with measurements that didn't fully match predictions. Beyond this boundary, space was not empty. Instead, it contained extremely thin matter, high-energy particles, and fluctuating magnetic fields. Temperatures were surprisingly high, though the low density meant heat behaved differently than we experience on Earth. The spacecraft also detected changes in cosmic rays, suggesting that even this distant region has structure and variation. In 2023, Voyager 1 faced a serious issue when it began sending corrupted data. Engineers on Earth managed to fix the problem remotely by carefully adjusting its memory, despite the immense distance. This demonstrated both the fragility of the spacecraft and the ingenuity required to keep it functioning. As its power continues to decrease, instruments are gradually being turned off to conserve energy. Still, it remains active, sending back valuable information. Its discoveries show that the space between stars is not silent or empty. Far beyond the boundary where the Sun's influence fades, the journey becomes even more mysterious. Voyager 1 is no longer exploring planets or moons. It is moving through a region that was once imagined as silent and empty, yet it continues to reveal patterns and activity that challenge that assumption. One of the most unexpected discoveries is the presence of continuous plasma waves. These waves travel through the thin gas between stars, creating subtle vibrations that can be detected by the spacecraft's instruments. Instead of complete silence, interstellar space carries a faint, persistent signal, almost like a distant hum. This suggests that even in the emptiest regions, particles and magnetic fields are constantly interacting. The magnetic environment surrounding Voyager is also far from simple. Scientists expected that once the spacecraft crossed beyond the Sun's boundary, the direction of the magnetic field would shift dramatically. Instead, the alignment remains surprisingly similar. This raised new questions about how the solar system interacts with the galaxy around it. It now appears that the boundary between solar and interstellar space is more blended than sharply divided. Cosmic rays, which are high-energy particles traveling through the galaxy, become stronger beyond the Sun's protective shield. Voyager 1 has recorded changes in their intensity and distribution, suggesting that they are influenced by larger galactic forces. These particles may carry information about distant events such as supernova explosions, giving scientists indirect clues about processes happening far beyond our solar system. Another important realization is that the heliosphere, once thought to be a stable bubble, is actually dynamic. It shifts in shape and size depending on solar activity and external pressure from interstellar space. Rather than being a perfect sphere, it may be stretched, compressed, or even distorted over time. Voyager's data has played a key role in reshaping this understanding. Despite its incredible distance, Voyager 1 remains connected to Earth through a fragile stream of radio signals. These signals grow weaker each year as its power supply declines. Engineers must carefully manage which instruments remain active, shutting down less critical systems to extend the mission for as long as possible. Every bit of data received becomes more valuable as the spacecraft approaches the limits of its capability. There is also a deeper significance to Voyager's journey. It is not just a scientific mission but a symbol of human curiosity. The golden record it carries contains sounds of nature, music, and greetings in multiple languages. It was created as a message to any form of intelligent life that might one day encounter it, though the chances are incredibly small. Still, it represents a desire to reach beyond our own world and connect with the unknown. Looking ahead, Voyager 1 will continue drifting through interstellar space long after its instruments fall silent. Eventually, it will no longer have enough power to communicate, and its signal will disappear. At that point, it will become a silent traveler, carrying its message through the galaxy for millions of years. Even in silence, its journey will continue. It will pass near other stars over vast stretches of time, though it will never stop or slow down. Long after Earth itself has changed beyond recognition, Voyager 1 will remain, a small artifact of a civilization that once looked up at the stars and chose to explore them. What makes this mission remarkable is not just how far it has traveled, but how much it has changed our understanding. It has shown that the boundary of our solar system is not a simple edge, and that the space beyond is not empty. Instead, it is a complex environment shaped by forces that extend across the galaxy. In the end, Voyager 1 is more than a spacecraft. It is a reminder that exploration does not end at the edge of what we know. It continues into the unknown, where each discovery leads to new questions, and where even the oldest machine can still reveal something.